In today's laboratory, we're going to make pipette rockets. It's going to be a little loud, it's going to be a little wet. Too bad you're not here with me. The fuel that we're going to use to propel these rockets, the two fuels are hydrogen and oxygen. Over here in red, this is going to be our oxygen generator, and over here in blue, this will be our hydrogen generator. We'll look over the chemistry in just a second. We're going to fill our pipette rockets, and here's one that I've already made, with different ratios of hydrogen and oxygen, and see if different ratios of the fuel makes a difference. This pipette bulb has been divided into 6 equal volumes, and that's what the black lines are for. Down here is the opening where we will fill it with hydrogen and oxygen. In order for this reaction to start at an appreciable rate that'll make this go flying, we have to add some energy. And we could add some heat. What we're going to use today is a spark of energy. And that's what we see over here on this other cart. This is our launcher. So the pipette, this pipette bulb, this hole will go between, the two wires will go right between the hole, and between these two leads, those two ends, you'll see a spark. I'm going to press the button over here, and that'll generate a spark over here. So if I press it, there's the spark. The hydrogen and oxygen, that'll get the reaction going. The energy that's released in this reaction should propel the pipette rocket across the room. The more reactions you have, the more energy that's produced, the further the rocket should go. On the floor are tape markings, and they're divided up into meter segments. This cart will go back here, and each tape marking is 1 meter. So there's 1, 2, 3, 4. There's the 5 meter mark. 6, 7, 8, 9. There's the 10 meter mark. I'm sure at least one will approach 10 meters. I know there's some obstacles in here, hitting a wall, so hopefully we don't do that. Hopefully my aim is good. There's no students in here, so I don't need to worry about hitting one of those. When you write down the distance, the smallest unit is ones. Hopefully in the data section, when you write down the distance, you go to the 10th of a decimal spot, and you write down meters. Step 1 in today's laboratory, we're going to add hydrochloric acid, this aqueous solution of hydrochloric acid dissolved in water, and add it to elemental zinc that's in this test tube. This reaction, which you'll be constructing in the conclusion section, elemental zinc reacts with hydrochloric acid. Specifically, the metal zinc in its elemental form will lose electrons to hydrogen in the cation, and the hydrogen will go to its elemental state. And for hydrogen, that's H2, hydrogen gas. So let's go ahead and add that. We should see some bubbling once we do. To add the hydrochloric acid, we need to remove this stopper. The stopper has a tube that goes through, so the gas that's produced in the test tube when we put the stopper back on will flow through this tube right here. So I'll add some hydrochloric acid. And put the stopper back on. And if you look, you can see the bubbling that's occurring. The zinc is in excess. The water's not reacting. Eventually this reaction will slow down when the hydrochloric acid is being used up and goes to much lower concentrations. But for right now, that's a lot of gas being produced. And again, it's being produced here, and it'll come up through the tube there. We'll put our pipette bulb there to get the hydrogen gas. Step 2, we're going to construct our oxygen generator. we're going to put a hydrogen peroxide solution, this is aqueous hydrogen peroxide dissolved in water, into this test tube. Hydrogen peroxide, it can decompose into oxygen and water. This reaction's happening right now. Oxygen is a gas, I don't see any bubbling, so this rate must be pretty low. When we add the hydrogen peroxide to this test tube, we'll immediately see some bubbling. What's in this test tube is an ionic compound that's black. There's a little bit of water in there from previous tests. There's the formula of this ionic compound. I'm sure you could draw that formula and write the formula of that cation. This black ionic compound is not reacting. It's a catalyst. And catalysts, which we'll learn about in upcoming chapters, can dramatically increase the reaction rate. And there's different mechanisms, but for this one, this catalyst, which is a chemical, weakens the hydrogen peroxide bonds. It weakens them so much that it's really super easy to break at room temperature. And we'll see a dramatic increase in reaction rate as soon as we add that solution. So I'll take the stopper off and twist it out and get some hydrogen peroxide, and as soon as I add that, you see that bubbling. Catalysts aren't consumed in the mechanism which they catalyze a reaction. This catalyst will still be there when this reaction slows down, when most of the hydrogen peroxide is used up. We'll probably have to fill up our test tubes with more reactant before we're done today. But for right now, that's a lot of bubbling. Okay, let's go on to step 3. Step 3, we need our pipette bulbs. I have our pipette bulbs, and we need a beaker filled with water. So I quickly did that virtually for you. I snapped my fingers again, and it appeared. What's the water for? We're going to fill the pipette bulb up completely with water. Why would we do that? Well, when we collect gas, when we put this opening over the tube, it's kind of hard to see the hydrogen go in since it's colorless. We'll fill this up with water completely, and then we'll put it over the generator, the respective generators. As the gas goes in, the water goes out, and the amount of water going out as it moves to the different lines, we'll be able to see how much gas, a particular gas, is going in. In our first test today, we're going to do half oxygen, half hydrogen. Doesn't matter which one we add first or second, but we'll do that. Again, this bulb is divided up into 6 equal volumes, although some of you may be looking at those lines and say, isn't that 7? This bottom line isn't part of the 6 equal volumes. The bottom line down to the opening, that's going to be a plug of water. That plug of water is going to keep all the gases in our pipette bulb when we're collecting it. So we have 1, 2, 3, 4, 5, 6 different volumes. So halfway, we'd fill it to the middle line of one gas, and then we'll go down to the plug. All of our tests today, we should have that plug of water. So again, we're going to fill this pipette bulb completely with water, and we'll put it over one of the generators. As the gas goes in, the water goes out. I have this tub here just to collect all my water, kind of minimize the mess that I'm creating. Although water evaporates, it'll be gone by the time I come back the next day. So let's go ahead and fill this pipette bulb with a 50-50 ratio. So the pipette, the opening is pointing up, and I'll just squeeze out all the air bubbles until it's completely full. Next, I'm going to put our pipette bulb on the hydrogen generator. It's completely filled with water, and you can see the bubbling go in. Maybe we'll put it a little closer. Oh, that looks like it's out of the view, so maybe I'll move it back. And we'll let it go down to the middle marking. So there's 50% of the amount that's going to be filled up is hydrogen. Next, let's do the oxygen generator. So there's the oxygen generator, and we'll stick the bulb on. And I'm going to leave a plug in there, and that plug of water will keep all the gas in there. So let's go ahead and take this to our launcher. We'll see how far it goes. Again, this data reading will be 3/6 oxygen, 3/6 hydrogen, half-half. So go ahead and put the 2 wires to that hole. The wires will extend beyond the water, and then I'll press the plunger. You'll probably see a little, as it ignites, the water will go out. And those of you that know a little bit about rockets, that mass coming out, that's what's making the rocket go the opposite direction. A little bit of momentum. So here's data point 1. So half-half. We'll do another one. And don't worry, I'm not going to make you watch me fill up every pipette bulb. You'll just have to trust me. But here's the 10-meter mark. So 9. So here's your pipette bulb right there. Go ahead and write down that data point in your data section. We'll do a second one. So this is the second test for 3/6 hydrogen, 3/6 oxygen. Let's go ahead and put it on the launcher. And press the button. This is why chemists or scientists in general make a lot more than just one test. And a lot more than 2. But 2 is all we're going to do today. So there's the first one. Here's the second one. So 10, 9, 8. Go ahead and write a data point, a length measurement to the right decimal place for the second test. 3/6 oxygen, 3/6 hydrogen, 50-50 mixture. The next 2 tests, one of them I'm going to do 100% oxygen and the other one 100% hydrogen. We'll do the same thing, fill the pipette bulb completely with water, and then go down to the plug marking. So let's get fill it up. And we'll do the hydrogen first. Get my blue and red right. So even though there's still lots of water down in the test tube, the reactants being used up, the hydrochloric acid, I don't have a lot of patience, so after this test, I'll put some more hydrochloric acid in there to speed up the reaction. Make sure we stop at the right plug marking. Wait for it. Again, this is going to be 100% hydrogen. Patience, don't fast forward that video. Almost there. Almost. Stay on target. Okay, go ahead and put it in. Trying to do things holding a camera. And we'll press it. I think you can hear that nothing's happening. Interesting. Pure hydrogen, no reaction. I took the pipette bulb off. Let's make sure our system was working, because I would think if you had hydrogen there'd be a reaction with a spark. Oh, there's still a spark. Only one reactant, didn't have both reactants, no reaction. Go ahead and write that as a data reading. What was the distance that that pipette bulb went? Don't forget the units. And yes, 0 is the number. Let's go ahead and test hydrogen for a second time. And I did put more hydrochloric acid, so it should go faster this time. Let's fill it up with water. Squeeze all the water out. Squeeze all the air out. And then, yeah, that's a lot faster. So pure hydrogen again. This is our second test. We'll stick it. You may not be, can you hear that? No reaction. So same data, same length measurement for the second hydrogen. Let's go ahead and do the same thing for pure oxygen, and then we'll do other mixtures. Here's an empty pipette bulb. Squeeze all the water out. And we'll go over to the oxygen generator. And I did just replenish the hydrogen peroxide with a new solution, so that's why it's faster. I don't have a lot of patience. Still waiting for it. Still staying on target. Down to the plug. Staying on target seems like a Star Wars quote, but I could be wrong. You always see those warning signs around pure oxygen. I wonder what's going to happen. Pure oxygen in our pipette bulb. So only one of the reactants. So again, nothing. But I'm a good scientist. I need to do it twice. So we'll fill this up again with water. So don't forget to make your length measurement for pure oxygen. That's funny. Pure oxygen, pure hydrogen. What was that famous Dr. Miller quote? I need all the reactants there to have a reaction. Only one of the reactants, there's no reaction. No energy produced. No shooting off of our pipette rocket. Almost there. And even though I lied to you, the other reaction mixtures, I will make you sit and watch me fill them up. But I wanted you to see these with pure gas and what happens. So go ahead and make your second data measurement for pure oxygen. Okay, let's go ahead and do a different mixture. This data measurement will be for 1,6 hydrogen, 5,6 oxygen. So we'll fill up the gas, we'll fill up the bulb and get rid of the gas, fill it up with water, and when we do 1,6 hydrogen, we'll just pull it out at that spot. And then we'll do the rest down to the plug of oxygen. And then I'll take it over to the launcher. So here's our first data measurements for 1,6 hydrogen, 5,6 oxygen. Slide it on. Here's 1, 2, 3, 4, 5. And there you go. Go ahead and make a measurement. And here's our second test for 1,6 hydrogen, 5,6 oxygen. And here we go. There's 5, 6, 7. There's the 8 one. Go ahead and write down your data point. Next, let's do 2,6 hydrogen, 4,6 oxygen. So here's test 1. Let's go ahead and write our data measurement. There's 5, between 5 and 6. And just note, our tests today are a little bit qualitative. These pipette bulbs strike and bounce, maybe roll or maybe not. But we're doing it twice. We'll just see what our data readings are. Let's do the second one. This is test 2, 2,6 hydrogen, 4,6 oxygen. Not sure if we have an outlier. Quite a distance with the two. There's our first one. 5, 6, 7, and then 8. So go ahead and, there's between 8 and 9. Go ahead and write down your measurement. We've already done 3,6 hydrogen, 3,6 oxygen. Our next set of tests will be 4,6 hydrogen, 2,6 oxygen. A ratio of 2 hydrogens per 1 oxygen. This ratio that we just did is 1 part hydrogen, 2 parts oxygen. Okay, let's go ahead and do the test. 2 parts oxygen, 4 parts hydrogen, 4,6 hydrogen, 2,6 oxygen. Here's kind of also the qualitative aspect, pulling it out at the right time when it hits my marking that was also made with a ruler qualitatively somewhat. And here we go. And we'll put in our oxygen. Looks like I need to replenish that. Filling up too slowly for me. I don't have a lot of patience. Let's take it over to our launcher. Test 1 4,6 hydrogen, 2,6 oxygen. And here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's number 10. So here's our first measurement for, here's my foot. Do the best you can. You can see the pipette bulb right there. There's 10 and 11. I think that's the furthest. I forgot what I did in the very first part of the experiment, but the higher the ratio of hydrogen to oxygen relative to no hydrogen, the further it's going. And it's a 2 hydrogens per 1 oxygen ratio. I wonder if that ratio agrees with the balanced chemical reaction that you're going to have to write in the conclusion section. Okay, let's go ahead and do test 2. And here's test 2. Let's see if it goes 10 meters. Not quite, but let's go measure it. There's 5. There's our 10 meter mark. There's our first pipette bulb. There's 10, there's 9. There's the bulb right here. So just do the best you can. Between 9 and 10. Hopefully say something closer to 9 meters. Okay, let's go ahead and do our last set of measurements. This last test will be 5,6 hydrogen, 1,6 oxygen. A ratio of 5 hydrogens per 1 oxygen. Squeeze out all the gas. And yes, I just put more hydrochloric acid in. Hopefully I get it out at the right moment. And then some oxygen. Let's go launch it. Test 1, 5,6 hydrogen. First measurement, let's get to the 5 meter mark. 6, 7, there's 8. There's our pipette bulb. Just go ahead and do your best to give a measurement. Hopefully you say something to the 10th that's closer to 8. 7 point something. And let's do our last one. And fill a little bit of oxygen in there. Here's test 2, 5,6 hydrogen. Big bounce, but that's okay. That's just part of the experiment. There's 5, 6, 7. There's the 8 mark. See the other one? And there we go. There's all of our experimental results for today. Should be able to answer all those conclusion problems. Don't forget to virtually clean up. And yes, I have to take the tape off the floor. And yes, it's too bad you aren't here in the laboratory. You would have gotten extra credit points if your pipette rocket would have struck somebody.